Lesson 6, conditional statements and their converse. So a conditional statement is an if-then statement. So if something happens, then something else happens. The hypothesis is the if part. So for our example, if it is raining, this would be our hypothesis. The then statement is like the reaction. What happens because of if? And it is called the conclusion. And we often say if P then Q. So our hypothesis is P and our conclusion is Q. And we write it P then Q. So what we're going to do is we're going to show if things are true and if things are false. So first we want to decide what a true statement is. So if it is raining is true, the false statement would be it is not raining. So this would be the false statement, this would be the true statement. We practice indoors is true. The false would be that we practice outdoors. So it's the opposite. So what we're going to do is we're going to go through each example. There's 4 different options with combinations of true and false. So the first is if they are both true. So if P is true and Q is true. So that would mean that it is raining. Which is true, and it's practicing indoors, and we know that that is true, because that's what the coach says. So altogether, if P then Q is true, we know that the result will be true. Our second option would be if they are both false. So if it is not raining, we practice outdoors. And that would be true too. Because if it's not raining, you're totally welcome to practice outdoors. So if P is false and Q is false, together they are true. If they're both wrong, in the end they're right. It goes against all logic, but it's right. Our third option is if our P is false and our Q is true. So we want our P to be false, so it's not raining. Oh, I spelled raining wrong. So that would be false. And we're practicing indoors, which is true. So if it's not raining outside, you still can practice indoors. No one says that you can't. So we know that this would also be true altogether. And our last option is if we start with true and our Q is false. So it is raining outside. So that would be true. And we want our hypothesis to be false. So we're going to practice outdoors. And because we know that when it's raining, you can't practice outdoors because that goes against what our coach has said, this time it will be false. So if you start with something that's true and end with something that's false, you will have a false statement altogether. So true, 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 false, false, true, false, true, 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 false, false. Seems really strange. But that is how logic works. That's how we go with our conditional statements. The converse of your statement is you say everything backwards. So we start with our conclusion, and then we have our hypothesis. Oh, first let's a Venn diagram for practicing indoors and outdoors. So we have, if you're practicing outdoors, and when you're practicing indoors. When you're practicing outdoors, you know that it's not raining. It cannot be raining for you to be practicing outdoors. But when it's indoors, it could be raining, it could not be raining. It doesn't matter. You can practice indoors no matter what. So this is what a Venn diagram would be of our conditional statement. So now the converse, we want to start with our conclusion as our if, and we want to end with our hypothesis as our then. So if we are practicing indoors, so that is our conclusions, then we say our hypothesis. It is raining. So now we check to see if this is true. So if we practice indoors, then it is raining. So this is partly true. We know that when you're practicing indoors, it could be raining outside, but it could not be raining outside. So this conditional statement, or this converse, sorry, is false, is untrue, because you can also practice indoors when it's not raining. So sometimes your converse will also be true, just like your original statement, and sometimes it won't be. So this is an instant where your converse is not true. Example 2, if you are north of latitude 60 degrees north, you can experience over 18.8 hours of daylight on June 21st. So first we want to see if this is true. So our hypothesis is that you are north of 60 degrees north. So that would be true. So you're saying that's true. You're north of 60 degrees north. Our conclusion is that you can experience over 18.8 hours of daylight on June 21st. So we know that that is also true because they're telling us this. So if P then Q, if P then Q, so we know P is true, Q is true, so we know altogether this is true. Now we want to see what our converse is. So if you experience over 18.8 hours of daylight on June 21st, then you are north of latitude 60 degrees north. So what this is saying is that only certain areas of the world will be able to experience over 18.8 hours of daylight, and it's usually very north. So if you experience this amount, then you have to be north of 60 degrees north. So this is also true. So P then Q, sorry, not P then Q. Q then P is true. Now we want to see if it's biconditional. And biconditional means that the converse and the conditional statement are both true. So because this is true and this is true, we know it is biconditional. Example 3. A person who cannot distinguish between colors is colorblind. So our hypothesis is a person who can't distinguish between colors. And our conclusion is then they are colorblind. So we know, so our conditional statement would say, if a person cannot distinguish between colors, then they are colorblind. So that would be our conditional statement. We want to write the converse and see if it is biconditional. So the converse would be, if a person is colorblind, then they can't distinguish between colors. And this still makes sense. Our statement is still true. Colorblind people can't distinguish between colors. So this is true and this is true, therefore they are biconditional. And for example, for our last example, a quadrilateral is a square if and only if all of its sides are equal. So we want to see if it's biconditional, so this is our conditional statement. Our converse would be, if all sides of a quadrilateral are equal, so we're just reversing this, then it is a square. So we have that backwards now. So the hypothesis before was that it's a square. The conclusion was all sides are equal in a quadrilateral. Now we have it backwards. So now we want to see if they're both true. So if all sides of a quadrilateral are equal, then it is a square. Now that is false. That's not true, because a rhombus is a quadrilateral and all sides are equal. And it is not a square. So this would be called a counterexample. Would be a rhombus. So therefore, it's not biconditional. It is just conditional.